In this recording, we're going to learn how to add and subtract rational expressions. It's not quite as straightforward as multiplying and dividing rational expressions, so we're going to start with simple examples and work our way up. We're going to start, in fact, with one that doesn't even have any variable in the denominator. So this first example, example 0, is not even a rational expression. But we're going to review how to add fractions with numbers and build on that skill in order to be able to add and subtract rational expressions. So in this example, we have two fractions. What you should remember from way back when is we need something when we add fractions. And hopefully it occurred to you it's a two-word phrase, a common denominator. So I need to think of the lowest number that 10 and 15 both go into. It's not the greatest common factor. That's sort of the opposite idea. It's the number that they go into. And so that number would be 30, right? So I'm going to make two fractions that both have 30s as their denominators. Because I know when I have two denominators that are the same, I can just add the numerators, and then I have my final answer. So my final answer is going to, or my next step is going to be something out of 30. Okay? But then I need to multiply each fraction by a form of 1, something that is going to make the denominator 10 into a 30. So that'd be 3, right? 3 over 3. So it makes a 9 over 30. That's an equivalent fraction. Now I need to multiply the 2 by something, and the 15 by the same thing top and bottom, so that the 15 turns into a 30. Of course, that would be a 2, right? So 2 times 2 is 4. Now that I have equivalent denominators, they're like terms, right? So I can just add the numerators, 13 30ths, and I've got my final answer. Of course, that can be checked with a calculator, whereas these rational expressions are a little more complicated. We'd have to store a number for the variable. So what we're going to do in this recording is we're going to do the odd numbers together, then you're going to do the even numbers on your own, okay? And then play the recording. So let me give you a chance to jot down this first example. This one happens to have a common denominator, so we're just going to add the numerators and keep the denominators. So we don't have to do anything fancy here. If the denominator is the same, it just says k plus 1. I don't add the denominators. I don't do anything. I just keep the denominator. The numerator stays k squared. I think I said k plus 1. It's k squared plus 1, obviously. K squared plus 3 in the numerator. And it's done. If you're tempted to do something with those k's, like canceling or crossing out or something crazy like that, it's not math. It's just not a math operation. Only math operation that would be involved is dividing. And we talked about in our last movie that you can only divide out common factors. And if you can't factor, you can't get common factors. So that's our final answer. Go ahead and work out number 2. Play the recording when you've got your answer. Okay, so hopefully you worked out number 2. If not, do that now. Pause the recording. Number 2 looks something like this. We're going to keep our denominator of 2a. Numerator is 8. 8 over 2a is 4 over 1a. We have our final answer. Okay. I'd like you to jot down these steps in your notes. These are the steps for adding and subtracting rational expressions. We need to get a common denominator if necessary. Okay, and we always multiply each fraction by what we call a form of 1. What I mean by that is, right, what we've got right here. 3 over 3 is 1. 2 over 2 is 1. So I'm not changing the value of it. I'm just changing it into something that is equivalent, but represented with a different denominator. It's kind of like taking a pizza that's cut into 8 slices and double cutting each slice. We usually do that for my kids. We double cut the pizza so it has 16 sixteenths, right? It's still one whole pizza instead of being 8/8. Different denominator. Next step, add the numerators, keep the denominator. Then the final step is just simplify if possible. I guess the only step I'd add in here is change step 0 here. I'm going to add in step 0. Rewrite subtraction as addition of opposites, if necessary. Okay, if you have subtraction, rewrite subtraction as addition of opposites. We're always going to do that. Sorry for adding in step 0 if you've already written out steps 1, 2, 3, but it just occurred to me. Okay? That'll save you a lot of aggravation later. All right, pause the recording and jot those steps down if you haven't already done so. Okay, number 3. This one and the one below both have common denominators. However, we're introducing a subtraction problem. So, in this subtraction question, we're going to do exactly what we just discussed. We're going to change it to addition of opposites. You might say, well, that's pretty simple, but it saves us mistakes. So now, when I add, keep the denominator, 4x plus 12, 4x minus 12, numerator, x squared minus 9. Just added the terms in the numerator. Of course, the numerator can be factored and the denominator as well, so we always try to simplify as possible, and this can be divided out. I'm going to have a common factor of x minus 3. Okay? Divide out, divide out. Our final answer is x plus 3 over 4. You work on number 4. Play the recording when you've got it done. Okay, so hopefully you've got number 4 worked out. If not, please pause and do it. We're going to change this to addition of opposites. We've got a 2x minus 2 up top. Keep the denominator x minus 1. The numerator can be factored. Divide the common factor, and our answer is just 2. All right, now we're going to start to introduce the notion of a common denominator that we're going to need to get. And again, we don't have a rational expression here because we don't have a variable in the denominator, but it's a nice warm-up problem. I'd like you to work through this one with us, and then you do number 6 on your own. All right, so this one we need a common denominator, and hopefully you'll realize that denominator should be a 6. What I like to do is write the denominators over here on the right. Those are the denominators I'm going to end up with. Now I'm going to come in here and multiply it by something, 2 over 2, to turn the 3 into a 6. But of course I have to do it in the numerator as well, right? So 2a. Over here I have to think about, okay, what do I need to multiply the 2 by to get to be a 6? Of course that would be a 3. Okay? So 3 over 3, top is 9a. That was the hard part. This is the easy part. 6 stays as the denominator. 11a is our numerator. Can't be simplified. You work on number 6. Play the recording when you've got an answer. All right, so hopefully you've got number 6 worked out. We're going to turn it into a plus negative 5. Doesn't really matter in this case that we do so, but it will be a good habit. Need to get a common denominator. Now in this case, unlike number 5, I don't need to multiply both of them. I just really need to multiply the right fraction by a 3. Okay, so I'm going to get them both to be 3b's in the denominator. The left fraction already had 3b, so you just leave it. The right fraction you need to multiply by 3 by. So now we just have negative 15. We add those numerators. We get negative 8 over 3b. And that's it. Can't be simplified. All right, number 7 introduces a particular special case here where the denominators aren't the same, but you might notice they look darn similar. X minus 4 and 4 minus x. If you remember back to our simplifying, we said these are not the same. They are opposite binomials, okay? They're not equal, but they're related. They have what's called a quotient of 1. That means if I had x minus 4 over 4 minus x, they divide out and leave a negative 1. I said before they have a quotient of 1. They have a quotient of negative 1, excuse me. So, what we're going to do to fix that is we're simply going to multiply the fraction on the left or the right by a negative 1. And I'm going to do it on the one on the right. Okay? So if I were to distribute that negative 1, it would make the x positive and the 4 negative, which is exactly what we have over on the left. So I essentially just got the denominators to be the same. I'm going to leave the one on the right alone. And I've got a negative 8 as the numerator on the right side. We just said if you distribute the negative 1, you're going to have negative 4 plus x. But if it's okay with you, I'm going to erase that and change that into x minus 4, right? Because it's the same exact thing. So I'm going to turn that into an x minus 4. And now I will have obviously the same denominator as opposed to just sort of close to the same denominator. All right, so obviously these are the same. 2x minus 8 over x minus 4. Something should jump out at you and say, wait a second, I know I can factor that numerator. Pull out a 2, x minus 4 over x minus 4. Those divide out. 2 is our final answer. Pretty neat. All right, I want you to try number 6. Excuse me, I want you to try number 8 on your own and play the recording when you've gotten as far as you possibly can or you want to check your answer. Okay, for this one, this was kind of tricky. What we need to do here in the denominator is factor it in order to determine what our factors are and what our lowest common denominator is. Of course, we're always going to change it into addition of opposites if it's a subtraction problem. This I'm going to cross out and replace it with its factored form, x minus 3, x plus 3. Now it should be obvious to you that, okay, the denominator on the left side has an x minus 3. This has an x minus 3. So what this one needs, that this one has, is the x plus 3, right? If this is not easy for you, you are not alone. This is challenging stuff. So we're tackling some really tough problems here, okay? We're going to do more of these in class together. Now they have the same denominator, right? It's pretty obvious. So the one on the left, x minus 3, x plus 3. And the one on the right is the exact same thing. So x minus 3 and x plus 3. Now you've just got your numerators that you can put together. So I'm going to distribute this out. So I've got x squared plus 3x. Okay. That looks like it can be added, and there's no like terms up in the numerator, but I'm guessing we can probably factor it. X squared plus 3x minus 18 all over an x minus 3, x plus 3. Looks like it's factorable here. Looking for numbers that add up to 3 multiplied to be negative 18. Thinking about 3 and 6. We'll make the 6 positive, 3 negative. And of course, we do have that common factor there. Our answer is right here. I'd like you to try this next one on your own. It's challenging. But now why don't we do this one together? I'll leave you the last one on your own. We'll do this one together. So we're going to first, of course, change it into addition of opposites. Okay? These do not share a common factor. You cannot factor either one of those denominators. So in this case, we simply multiply each one by the other. It's very tempting to put a plus 1 here. It just doesn't work mathematically. I can show you that in class, how you can't add something to the numerator and denominator of a fraction. But what you can do is you can multiply the top and bottom by something. So we're going to multiply this one by x plus 1. We're going to multiply this one by an x. All right. And then we've got a 3x up top over an x plus 1. You might be asking, Mr. Clinton, why don't you distribute this out? And the reason is because later I'm going to want to factor it to see if I have any common factors. So this is just, you're going to be undoing that work in a moment. Here, this is where it's going to pay off. If you don't change this to an addition of opposites, likely you're not going to remember that we're subtracting the 2 as well. So it's going to be negative 2x minus 2. This is where it's really going to pay off for us in terms of getting the answer right. Okay? Add your numerators. 3x minus 2x, x minus 2. And the denominator is just what it is. Okay? Great. Now, on your own, I'd like you to try to do this final example, which is very challenging. You're going to have to factor all this, and find out what the common denominator is. Then play the recording after you've gotten as far as you possibly can. Okay? Okay, hopefully you paused and got as far as you can. You factored this denominator and you factored this denominator, and this is what you came up with as your denominators. Y plus 1 and y plus 2. Over on the right side, difference of 2 squares. Y plus 1, y minus 1. In terms of what this one needs, this one over here needs a y plus 2, right? Because this one had 1, this one didn't. This one on the left needs a y minus 1. You don't need an extra y plus 1. They share that factor. So we distribute the numerators, and we end up with y minus 1 on the left, 2y plus 4 on the right. So at this point, we can just combine the numerators because we have like denominators. So those numerators combine to 3y plus 3
over that same denominator. We don't do anything with the denominator. We don't distribute it out. We don't change it in any way. It's just what we are adding. We have y minus 1 of these things plus 2y plus 4 of these things. There's a common factor I think you noticed in the numerator of 3. Let's factor that out. And what's cool is these common factors of y plus 1 are going to divide out as well. So those divide to 1. And we just have in our final answer 3 over y minus 1 in parentheses times y plus 2 in parentheses. Thanks for watching.